This is a worked example on how to solve an inequality involving a power function. So this is actually the second worked example for the same category of problems on a worksheet, but I wanted to include this problem as well because this highlights a more algebraic solution as opposed to the creative solution we saw in last video. And just to be clear, you do not need to see the previous video of this worksheet to understand how this problem works. This is a standalone problem. What I will do first is I will do a quote-unquote bad solution, or just the less optimal solution. You might be able to, wrestle your way into the correct answer here, but let's just look at what would happen if we tried to use a common mistake. So the first thing I'm going to do is raise both sides to the third power. This will cancel the 3 from my 2 over 3, and we have that t squared is less than or equal to 64. Now I can root both sides, and I get t is less than or equal to plus or minus 8. Now, what's not necessarily clear here is if I split this plus or minus 8 into two distinct solutions, I have t is less than or equal to 8, and t is less than or equal to negative 8. And on a number line, what this looks like is that I have the spot 8, I have the spot negative 8, and t exists everywhere behind both of them. So you might be tempted to say, okay, well, my solution here is negative infinity up to 8. But this is actually incorrect. And you can kind of figure out what the actual solution is. And this is a slightly easier problem, but I want to demonstrate the correct way to do this because you will need to be more careful for more complicated problems. So let's actually see what a solution would be. So the first step is actually correct. We are allowed to take the third power of both sides because we are allowed to raise to an odd power. An odd power will preserve inequality. So now we have that t squared is less than or equal to 64. But the difference in this solution is that we don't want to take the square root of both sides because this is going to complicate things and lead to extraneous solutions. What I want to do instead is then move my terms to one side of the equation and try and solve this like a polynomial. Right? I got rid of the fractional power, but now that I have a normal power, I want to treat this like a normal polynomial equation that we're used to solving. So from here, I can factor this into t minus 8, t plus 8, and I get the zeros of t equals positive 8, t equals negative 8. And then if I put this on a number line to make a sign diagram, you can see that I get, negative 8, positive 8, both come from positive linear terms. I will get a positive interval, a negative interval, and a positive interval. And we're looking for where this is less than or equal to 0. And so the full answer is the interval between negative 8 and positive 8. And it's not that this is impossible to deduce from this line right here. You can kind of figure out that that's where we're headed. However, it is better to do it in the green solution that I have here, as this format of solving an equation will be more reliable for increasingly complicated versions of this problem. So that's just a easier example, but I'm just trying to outline the method that you'll want to use for other questions on this packet.